Welcome. Today we will see single-threaded and multi-threaded process using Python code as example. I have built a basic user interface using the tkinter library. Now let's run the program and see what's happened. So when I run the program, the operating system load the executable code into memory and process created. We can say process is a running program in our computer. Process include the resources that are important for execution, like instruction, data, and memory addresses. But there is also a basic thing, thread. Thread is the smallest unit of execution inside the process. A process must have at least one thread. Process without thread means instruction without execution, because the key components needed for execution are controlled by thread. Those components are program counter, stack, register, and so on. I think thread is clear right now. Let's get back to our code. This code is single-threaded. The program follows a single flow of execution. What we mean by that is it executes one instruction at a time, step by step. In this messy GUI, you can see a button loop without thread. When I click the button, it calls the loop function. Inside this function, there is an infinite loop. As you can see, the while loop condition is always true, so this loop will iterate forever. Let's run the GUI and see what will happen. Okay, I'm clicking the first button. What is happening? Doesn't work, it's blocked. Okay, the loop function block everything. I can't even click another button. This happened because my program is executed in a single thread. Due to this, my program executes one instruction at a time, so it is stuck in the while loop. What is the solution to make my GUI responsive? Yes, I think I should use multi-threaded process.
Okay, let's use a multi-threaded process. So let's import library import threading. So this library enables us to create a new thread in Python code. So now I will create a new function. Let me call this function loop with thread. So inside this function, I will create new thread by using this library. I will create new thread. So let us create this thread by using the threading. Then I will call thread. Then my target function is this loop, this blocking function. So I will call it self.loop. Then let me make the daemon equals to true. This will create a daemon thread. Daemon thread run in the background, and it also automatically terminates the thread when I stop the main program. So it is beneficial to make this true, and then I will start the thread. Okay. Now this function will create a thread, and this newly created thread will run this blocking function. So the blocking function will not be block further our main function. So that's what we want. Okay. Then this loop with thread button, when this button clicked, I want to call this function. So let me call it loop. Loop with thread. Okay. Now when this button clicked, it will call this function. Then this function will handle this blocking loop. Okay. Let's save it before running, let me add a print statement here, which give us a message when this loop is running. So let's say loop running. Okay. Now let's save it and let's see what will happen. Okay. Now previously when we clicked this button, it was blocking everything. Now I used a multi-threaded process. So when I clicked it, yeah, it's the loop is running. It's showing the print statement. So it is not blocking my GUI. I can't even click this button and show the message box. It is not blocking. So this is the benefit of a multi-threaded process. It's enable parallel execution, and it also enhance our program performance. Also, creating a thread is not that much resource intensive, so it is much more beneficial. Okay, thank you.